I currently use Pandas daily in my data science role. Even before I switched into the data world, I used Pandas quite extensively as an Excel replacement starting back in 2020. Coming from an industry where all my other colleagues only knew Excel, Pandas gave me superhuman ability to analyze data much faster than my peers. I became known as the guy that could crunch through data at breakneck speed and find patterns in our data that others couldn't. Needless to say, I've grown quite attached to this Python module. However, Pandas traces its roots back all the way back to 2008. Although the maintainers have done a great job of keeping it updated with modern features such as method chaining, it feels like the package has started to show its age. I typically find myself only using a handful of the methods, and the rest of it just kind of feels like bloat. This means that when you're looking up help online, there's typically several different answers for performing the exact same task. If you're new to Pandas, this can quite quickly become very overwhelming. Polars recently introduced version 1.0 earlier this week. As a longtime Pandas user, I got curious if now was the time to finally make the switch. So I started looking into the user guide and decided it would be worth looking into the new framework. Typically, the main selling point Polars makes over Pandas is that it's faster processing speeds. Although fast processing speeds is always a nice to have, I knew I personally wouldn't be enough to justify making the switch. Most of the data sets I typically deal with are about 100 to 100,000 of records or less, and typically less than 1 gigabyte in size. Pandas can typically handle this volume of data without much problems. Instead, most of my time is formulating my ideas and writing the actual code instead of waiting for the queries to execute. So what really piqued my interest in Polars was this migration from Pandas page in the user manual. So Pandas was initially designed for panel data in the quantitative finance world. This meant it was designed to allow multi-indexes, which allowed you to represent a set of two-dimensional tables in a three-dimensional or even higher dimensional space. Although this might be a great feature for that particular use case, I often find that for most ETL processing tasks, this simply isn't necessary. However, Pandas will often force you to deal with it regardless. And this leads me to my first reason that I decided to make the switch from Polars to Pandas. Polars decided not to implement an index for its data frame data structure. Instead, every row is uniquely indexed by its integer position. As a result of this decision, it therefore does not implement multi-indexing. I find that in Pandas, most of my bugs and headaches are just due directly fighting with the data frame indexing and multi-indexing structure. So let's take a look at examples so you can see what I mean. So here I have two notebooks open. On the left here is Pandas, and on the right here is Polars. So in each of the case, I'm just going to connect to this local SQLite database. And then I have a table with just the transactions. So let's say I want to do a simple aggregation here. So let's say I have the billing country, and I want to know how many transactions occurred in that country, what was the mean transaction, and then what was the total transaction count. And then finally, let's sort it by the total revenue and then decreasing order. So to do that in Pandas, we would go here and start here. So let's go in and run, import our libraries, and set up our connection. So to do this in Pandas, we would first use df, and then we would say, okay, let's do a group by. And what do we want to group by? We want to group by the billing country. And then now we want to do an aggregation. So the aggregation we would want to do is first we want to go and do the total count, right? And so for Pandas, at least to my awareness, you have to specify a column when doing a count. So for this one, I'm just going to say the customer ID, even though it really doesn't matter which column you pick here. And I'll specify this as count. And then the next one we want to do is we want to take a look at the invoice amount. So total column. So let's do total here. And in order to do two aggregations on this, we'll have to use a list here. So we'll do a list and we'll say the first one we want is going to be the mean, and the second one we want is the sum. And so we can aggregate this and we get a result back. So awesome. But there's only one problem here. This really isn't the greatest format if you want to keep using this table. So now instead of having one index on the columns, we now have two. So on the most innermost one, we have the count, mean, and sum. But then on the outer one, we have customer ID and total. And the reason this happened was because I specified a list on the total. So now there's two columns that are under the total column. And then the other thing is it actually went and implicitly made my the group by column, which in this case was billing country, as the index. So right off the bat, I need to reset the index if I don't want that to be my index, which typically I really don't want it to be my index. So that gets rid of that, but then we still have this multiple tier indexing. And so what you need to do here is that you need to go and say, okay, drop a level. And then you want it to be, on this case, I'll say, okay, let's do drop 1, comma 1, which is going to be on the column axis, drop the first level. And we get this. But this still isn't really great because I don't want 2 total columns, and I want this to be a count. So to do this in a declarative manner, you could do something called .rename. But the issue with this is that since I have 2 total columns, I can't use this rename method because it's not going to be able to properly distinguish which total column I want to rename. So typically what I find when I'm doing this workflow in Pandas is I have to go here and rename this as something like df.ag, and then go through and actually implicitly tell it, hey, my columns for df.ag, I want that to be equal to what I want to name it. And so in this case, I would say, okay, we want to keep this as billing country, and then we want this to be the count, this to be the mean sales, and then this to be the total sales, right? And we could do that, and we should get the result we need. And then finally, I said I wanted to have it in descending order, so I could do, okay, sort values. And then I could say by, and we'll do it by, we want to do it by total sales, and we want it to be ascending equals to false. And this needs to be S, sort values ascending. So this works out, but we had to do a few extra work here. So for instance, we had to do the reset index, we had to do this drop level, and then again, we had to implicitly put the column names here. So let's see how this would work out using pollers. So in pollers, we're going to do the exact same thing. Let's import our pollers as PL, and then let's read in our database. So let's see how we do the same aggregation in pollers. So first we could go here and say, okay, take our DF, and again, we want to do a group by. So we'll do group by, and what do we want to group by? We want to group by our billing country. And then again, we'll specify the same thing as ag. Now the difference here is that now we can, we don't, the way this ag works is we actually don't need to pass it a dictionary. We're just going to pass it a set of arguments, which in this case, we will just set it to a, we typically would set it to what's called expressions in pollers. So let's see how that would work out here. So I would say the first one I want is PL. There's actually a special function, a special method here called a length that will give me the count. And then if I want to rename it, I actually just rename it directly in this aggregation. So I don't need to do a call after the fact. So you call the alias method, and then let's say this would be the, what do we want to call this? We want to call it the count, right? And then we could do some more here. So again, we want to select our, which column here? We want to select the total column. And then we could call a mean on it. And then again, we'll want to alias it. So we'll say an alias of mean sales. And then again, we'll do one more here. We'll do PL column. And again, we want this to be our total column. And then we'll do a sum. And let's alias it again with the name that we want, which in this case would be total sales. And let's execute this. And here you can see we get the result. And as you can see, oh, and we also need to sort the values. So let's go ahead and sort values. Sort values. And we want to sort it by, again, we want to sort this by the total sales. Sort. So it's actually not sort values, it's sort here. We'll sort it by total sales. And again, we want this to be descending. We want this to be true. So it's actually backwards. On Pandas, you specify ascending, and then pollers, you have to specify descending as the argument. So here we can see we get the same exact result as Pandas. As you can see, we didn't have to mess around with the index, the multi-level index, and then the renaming was much more elegant than the way we had to do it with pollers. So overall, I think this is a lot easier to implement than using pandas. So that's the first thing. You may have wondered why I made such a big deal about why I was forced to explicitly set the columns properly in the pandas data frame. Operations in which you explicitly work on the data structure, such as directly setting the columns property, is known as imperative programming. However, when we are method chaining in pandas and polars, this is an example of declarative programming. In this paradigm, you specify what you want your results to look like, but you don't explicitly tell the computer what steps to arrive at the desired outcome. This leads me to my next point about polars, which is that it implements declarative programming in a much more elegant manner than pandas. So let me show you another example. So here we're going to take another look at another table in this database. So we're going to pull in our employees. So let's say I want to do a simple query on this. And let's say I want to get all the employees that are involved in sales, the sales in this organization. And instead of having a field with just their last name and first name, I just want to have one field that has their full name. So let's see how I could do this in pandas. So let's read this in. And then we'll go here and say, okay, so what's the first thing we want to do is we want to call our df, and we want to do a filter. So there's a few different ways you could do this in pandas. The way I prefer to do it is the declarative way, which you typically would do with the .query parameter. And so the way the .query parameter works is that you specify a string in this method, and in this string, it'll implicitly evaluate it using the eval method built into Python, which can take a string and basically convert it into executable code. And this will allow you to actually directly specify the columns that are within the current context of your data frame. So for example, I could go here and say, okay, what do I want to do? I want to filter the title, right? So I could say title dot string dot contains, and we want it to contain the name sales, right? Which is great and all, but the issue is, let's say I haven't really used this in a while, and I want to get the most out of my linter and be able to see what methods are available. Since this isn't a string, I'm not going to get any sort of type hinting on this. For example, this contains, if I hover over it, you'll see I'm not getting any type hints in terms of like what parameters it needs or any description of what this function does. So typically what I'll have to do is instead I'll have to go here and say, okay, pull me this and then get me the title dot string dot contains. And then on here, now I can kind of see the linter and actually pull up the type hints and then get all the information that I need in terms of what what arguments it's expecting for this function. So this is really not ideal, but we can see this will execute correctly, and we'll get the only the people that have the sales in here. And now for the next thing, I said I wanted to make it where I just had one field here, so I want to get the last name and the first name. So the way you can do this in the declarative manner in pandas is the assign statement. So what the assign statement takes is you first pass in what you want the new name to be. So in this case, I'll say it's going to be a full name, and I'll say what I want to be. And so at the second point, what you need to do is actually, you can either define a function already that you want to pass here, but typically what you see is people just give it an anonymous function, which in pandas you would just say lambda, which is basically an anonymous unnamed function, and then give it the parameter name. The typical syntax that people use is they specify as x. So x here is actually going to be the data frame in our current context. So it's going to be actually this data frame right here, our filtered data frame. And so here I can just say, okay, x, and I could say first name plus this, and plus x dot last name. And then again, if you see here, if I try to use linting, so if I do like this dot string dot, and I'm pressing, you can't see it, but I'm pressing control space on my control bar right now, it's not going to give me any type hints. Or if I do, dot contains, if I do this again, I'm not getting any sort of linting comments. Really, again, this isn't really ideal if you want to get the most out of your linter while you're doing this declarative syntax. So, but again, we can run this and you can see, indeed, it'll run and we get the answer that we want. If I scroll over here, I can see the full name. And then finally, we don't really want all this other information here. So the next thing we have to do is we have to select the columns that we're actually interested in. The way you do this in pandas typically is you just do this double bracket notation where you first you have a list of lists essentially. So on the list of lists, you give the inner list the columns that you want. So in this case, I just want the title and I want the full name. And then I get the answer that I'm looking for. So that works out and all, but again, this doesn't really tell you what action it's doing. So if you're a new user, this double bracket notation, it may not be really intuitive to like what you're seeing here. You may not understand like, hey, I'm actually only subsetting a certain amount of columns. So let's see how we can do this in polars and see if it's any better. So again, I'm just going to pull in the database here for that table, and let's see what we can do here. So let's take our data frame here, and how would we do the query? So the way we do this in polars is we use the filter method. And now that we're in the filter method, we're in a separate context. So again, like our other ones, we would pass in a expression here. So I could do PL, and what I want to filter on, well, I do PL.call, and we want this to be title. And then now I can say, okay, .str, and then as you can see on my on VS Code, I'm now getting linting here, so I can actually see this method. And then I want to get the contains, so I can see it here. I can use the type hinting to auto-complete it. And then now I get all the, I can easily see what expressions I need here. So I can say, okay, well, I want this to be contain sales. And then this will, again, get us what we were looking for the first time. So it gets us the same answer as Pandas, but as you can see, we're now getting the most out of our linter. And so now we're getting auto-completion, type hinting, and all the really good stuff that you want from your modern IDE. So let's see how we can do the assign statement. So with to do assign, typically what you do is select, which again puts you in a new context. And this is similar to the select statement in SQL if you're familiar with that. And so we could just say, okay, well, what do we want? Well, first thing we want is title. So we can give it the option of either an expression or a string. So we could give it an string if we say, hey, we just want to select this column, but we're not going to do any sort of manipulations on it, and we don't want to rename it. So I can just give it the title here. And then for the full name, we would again give it an expression. So we could say PL dot column, and we want it to be the full name, the first name. And we want this to be, we want to add a plus, and then we want this to be the last name column. And then again, if we want to, this operation is just going to return a polars expression. So that means we can actually just call a alias on it. And again, I'm still getting the type hinting. And I'll give it the alias of full name. And then if we run this, you'll see we get the exact same answer that we got in Pandas. But the other additional thing here is that you'll see we got tons of type hinting, tons of linting, tons of auto-completion. And the other thing with the select statement, we actually specified, hey, these are the only two columns that we're interested in from this point forward. So we actually didn't even have to go through and subset it like we had to do in Pandas. So overall, I think this is a much better way to use a declarative syntax. So these two reasons are already good enough for me to actually make the switch. However, let's take a look into the main selling points that are typically made for polars. So polars is written in Rust, which is known as a great language to write concurrent applications in. And you can do this in a safe manner because it avoids common bugs such as race conditions that can often plague system-level programming language if the programmer isn't careful with how they program it. So this leads us to the next reason for switching, which is that polars is parallel. And so this means that you can run it on all your CPU cores, and you can be rest assured that it's going to run in a safe and consistent manner. So we're in a current age where CPU vendors really just don't increase the clock speed much from generation to generations on their CPUs. And so if you want to get the most performance out of your processor, you need to take advantage of all the cores, because typically from generation to generation they keep adding more and more cores to your processor. However, this means your software needs to take advantage of the additional cores. Unfortunately, Pandas only works on a single core. So this means if you have a machine with several cores, most of your CPU is not going to be utilized. So let's take a look at an example at this. So for this next example, I'm actually ran a script that just made a CSV file with about, I think it has about 80 million rows of data in it. So it's not too big. I think It ends up taking about maybe 1 gigabyte of memory, 1 gig of memory. But let's see how we would run this query in Pandas. So what I want to do here is I have only 2 columns in this data set. One's called a label, and the only values it can take on are the literal values of A, B, or C. And then I have a data, which is just a floating point number that was randomly assigned. So what I want to do here is I want to read in the CSV file, and then all I want to do is say, okay, let's group it by the label, and then we want to aggregate it on data, and we just want this to be, let's say, the mean. And so we can run this in Pandas, and as you can already see, I already ran it. It took about 16 seconds. But before we run this, let's see if we can monitor the CPU usage on my computer. So what I'm going to run here is pull up the statistics on my processor. So here you can see I have 8 cores on this processor. So let's go ahead and execute this query and see how it does on the processor load. So we'll run this here. So we're running it right here. And as you can see, core 3 is loaded up at 100%. But nothing else is really being loaded up. The rest of them have a slight load because I'm screen sharing right now. But really, none of the other cores. Yeah, now you can see it swapped to core 0. Still running here. Now it's swapped to core 5. And you'll kind of see it's kind of ping-ponging around from which core is running the Pandas query. The OS is just swapping it over from core to core. And then you can see it finally ran in 33 seconds. So this really isn't ideal. So that we didn't really utilize the most of our cores. So let's see how we could do the same query in Polars. In Polars, we're going to use the method called scan CSV. So we'll call scan CSV, and let's do the same thing. Let's do a group by, and we want this to be by label, and we want to aggregate it by. We want to aggregate it, and we want to aggregate it by the PL dot column. We want this to be data, and let's do the mean dot mean. So again, before we execute this query, let's pull up our performance manager so we can monitor our cores. And let's go ahead and execute this query. Oops, actually before I do that, I need to actually call the .collect method. So let's call .collect, and I'll get more into what collect means here in a minute in the next section. So let's call this here, and let's press enter and monitor the performance. And as you can see, all my cores are now quickly shot up to 100%. And now you can see the actual, yep, and we're done here. The cores are back down to its base load prior to that. And you can see basically this execution took about 6 seconds versus Pandas, which took 33. Because this one was able to utilize all the cores on my machine. They all ramped up to 100% and quickly performed the operation. So although you can write Pandas in a declarative manner, it still will execute each step you specify in a sequential manner. So in a sense, you're still writing your query in a somewhat imperative manner. If you ever dealt with an SQL database, you'll know that SQL is purely a declarative programming language. The DBMS will go through and evaluate the whole SQL statement you've written and then figure out the most optimal steps to perform the query. This leads to the final point that Polars takes a similar approach to SQL known as through a feature as lazy loading. So when you write a Polars query in this manner, it does not perform the query until you actually specify you actually need it to be executed. So as you noticed in the last example, I had to specify a method called .collect in the last statement of Polars. This is where I actually specified to Polars that I wanted to execute my query. Waiting for as long as possible to execute your query allows the Polar optimizer to formulate the fastest way to perform your query. So let's go through another example and show this in action, how this works. So here again, I'm just going to actually copy this last query that I did. So we'll copy this here, and let's just paste it down here. So let's say I want to read this same query in Pandas, but let's say I only wanted to do it on the first 1,000 rows of data. Now I know you're probably thinking, hey, this isn't the most optimal way to do this in Pandas. If you only want 1,000 rows, you should specify in this read CSV file. But for the sake of the argument, let's just say you're writing a query, and let's say for some reason you only specified it here, which is often the case when you're when you're doing exploratory analysis, you're not going to be thinking, oh, what's the most optimal way to construct this query? So, even though this is maybe a bit contrived, in the real world, this is often going to happen where you're not going to be thinking about performance when you're writing your queries. So this is a suboptimal query for Pandas because it's going to go through and have to read in all 80 million rows of data, even though we only wanted the first 1,000 before we did this group by. So we could, again, run this in Pandas and let this run. And as you can see, this is going to take basically the same amount of time that we took for the last query to run. So our query went ahead and ran, and as you can see, it ran a little bit faster than the last one, but not much. It took about 25 seconds to run this query. So let's see how we can do the same thing in polars. So let's copy this here. Oops. We'll go copy this here, and again, we're going to paste it down below here. And the first thing I want to go through and actually show you here is that this scan, it actually pulls in a special, if you go in through here, and if I do this scan, you'll see it actually doesn't directly show the data frame. So whenever you use these scan methods, it pulls in your data frame in what's called a lazy mode, which means that you're just saying, hey, these are the steps I want to take, but don't actually execute them yet. So if you're using a data frame that's not in lazy mode, all the way you need to do it is just specify this .lazy method. And this will tell polars that, hey, I want to do lazy from this point forward. And then let's say you write some methods, so you write some methods. And then once you're done with all your methods that you want to run, you specify this .collect method. And this says, hey, now go ahead and execute the query. So let's see how we do that last example again, but this time using polars. So we'll go here and just add in the .head method here. And we want to only specify 1,000 rows. So let's run this query and see how long it takes. And that basically took instantaneously. So the reason polars was able to execute this so fast was because it was able to look at the whole query that we specified, and it basically determined like, hey, you only need 1,000 rows of data, so I'm only going to read 1,000 rows of this CSV file. I'm not going to load all 80 million rows. So that's the 4 reasons why I am planning to switch over to polars. So let me know, are you considering switching as well? Let me know down below in the comments. Or are you planning to stick with Pandas, or maybe something else? Also let me know. If you want to check out the code of using this video, see the link below for the GitHub repo. That's it for now. I'll see you all in the next time. Thanks for watching. Bye.